All right, so we're going to look at is the chain rule now, and the chain rule is probably the most complicated idea in taking derivatives. So when do we use the chain rule? When we have a function encapsulated into another function. So if you remember how y equals x to the 10th worked, now we have y equals something to the 10th. So the way the chain rule works, and this is the symbolic way to represent that, basically if you're taking the derivative of a complicated function, it's the derivative with the complicated part included, and then you multiply by the derivative of the inside. So in this first example, the inside would be the 4x plus 5. So that means that the derivative of this function overall is going to be 10 times the thing to the 9th, and then the derivative of the thing. So the derivative of 4x plus 5 is 4, and then we simplify reasonably if we're able to. So this is the derivative of the original function there. And that's it for that one. Okay, moving to another example. Now we have a square root of something, which I'm going to go ahead and write as 4x squared plus 7 to the 1/2. So now we're taking the derivative of something to the 1/2. Well, that means the derivative, which I'm going to write as dy dx, is 1/2 times the something to the negative 1/2. Now the something is still 4x squared plus 7. But now I'm going to multiply by the derivative of 4x squared plus 7, which is 8x. And now, of course, we simplify if we can. Notice that the 1/2 and the 8x are both outside the parentheses, so I can collect those together to write 4x. Is that a new ghostwriter thing? I don't know. 4x squared plus 7 to the negative 1/2. Notice I'm not trying to manipulate that negative 1/2. It's a quantity to the negative 1/2, which means I cannot simplify it anymore. Now, one thing you can do is if you want to write it without negative exponents, remember that was a thing back in algebra, we could write 4x over 4x squared plus 7 to the 1/2. And if you want to take it one step further, we know that 1/2 powers are more commonly known as square roots. So you could even write this. And this helps tie it back to the original function. It's related to another square root. So any of these three would be acceptable for me for now. So if you're watching this and you're taking it from another instructor, obviously follow your instructor's guidelines there. But any of those three are fine. So I thank you for watching. That's a little introduction to the chain rule. In the next video, we'll intertwine the chain rule with product and quotient just to show that we can combine these rules of derivatives. So that sounds like such fun, doesn't it? Thanks for watching and stay tuned.